So laws of logs, these are preparation for the differential equations section of the course. And we have 6 laws on the right hand side. How I refer to these is when you multiply with numbers, you add with logs, that's the first one. When you divide with numbers, you subtract with logs. If you have a power inside a log, you can take that power out and multiply by it. The fourth one I don't usually use and rarely comes up in applied maths, that's the change of base formula. And then the last one is the change of base formula as well. I rarely use that also. So we'll be focusing on the first 3 with the following questions. So expand each log. I'm going to look at number 1. So what we have here is the product of numbers. I'm going to change the product to a sum using the first identity. Okay. Now what we see then is we've got 7 to the power of 4, we got 5 to the power of 3. So I've got powers, I take those powers out and put them in front of the logs. And that's my answer. Number 2, same idea. We're multiplying 2 terms there, so I'll change the multiplication to addition in logs. And then we've got an m to the power of 6, take the power out so it's multiplied. And you'll see that when we go between these log stages, or using these log identities, we're actually going down the order of operations. So multiplication becomes addition, division becomes subtraction, and powers become multiplication. Okay, moving on. So these ones, will you guys do them? Okay, that's the answer. Pause the video if you need to do the next one. Obviously there's a mistake there. Because we're dividing by the 2 terms, there should be a minus between both of those on the right hand side. So the answer is 4 log to the base 15g minus 6 log to the base 15r. Okay, for you guys, pause the video and do these. Okay, the next one, there are the answers. Pause the video, correct them. The next question. So, if we look at the example that I give above, we're going to evaluate expressions now. So the expression is log to the base 7 of 49, or log 49 to the base 7. So what we want to do here is write the number, the 49, as a multiple of 7. Actually, we want to write a 7 squared. So in the second line, we have log 49 to the base 7 is equal to log 7 squared to the base 7. And then when you bring the 2 in front, you get 2 times log 7 to the base 7, and any number to the same log works out as 1. So log 7 to the base 7 is 1, log 10 to the base 10 is 1, or for us, log e to the base e is 1. All right, will you do the next 6 questions? So pause the video, and here are the answers. Okay, I'm going to keep going. All right, evaluate an expression. So we have log 8 to the base 2 and log 9 to the base 3. So like the previous example I did, I'm going to write 8 as 2 to the power of something. So I'm looking at the base and I want 8 as that base to a certain power. So it's 2 to the power of 3. I have log 9 to the base 3. The base is 3, so I want to rewrite the 9 as 3 to the power of something. So the second line, I get log 2 cubed to the base 2 and log 3 squared to the base 3. I can bring the powers out in front, so I get 3 times log 2 to the base 2 and 2 times log 3 to the base 3. And again, the log of any number to the same base will equal 1, so we end up with 3 times 1 plus 2 times 1, which is 5. Will you do the next 6 questions? Pause the video. I'm going to keep going. There are your answers. Okay. The next set of questions that I'm going to just talk about uses the equality rule on the left-hand side and the bottom. So if you have log of a number to a certain base equals log of another number to the same base. So there's log on both sides, you have log equals log, there's no plus anything else, and the bases are identical. Then you can cancel off the log to the particular base and just get m equals n. And there's an example to the right of that as well. So log 3x minus 4 to the base 8 is equal to log 5x plus 2 to the base 8. Now you have log to the base 8 on both sides. You can cancel those off. You're just getting the anti-log to the base 8 on both sides, so that cancels those off, in which case the things in brackets are equal and you can solve for x. Now that's the method to do those 6 questions, so pause the video and do them. Here are the answers, and I'm moving on. Okay, if we look at the left now, we have a couple of identities that are quite useful that you might see over time. So the first one is log 1 to the base a is equal to 0. The reason for that is 1 is a to the power of 0. And when you take the power of 0 out in front, you get 0 times log of a to the base a. So that's 0 by 1 equals 0. The next one, log a to the base a is 1. I mentioned that already. The next one, log a to the power of r to the base a. Take the r out, so you get r times log a to the base a, and any number to the same base within a log works out as 1, so you get r by 1. Number 4, in that case, you can rewrite the 1 over b as b to the minus 1. So that would be log of b to the minus 1 to the base a, and take the power of minus 1 out, gives you the thing on the right. The next one, I generally don't do. The next one, I don't do either. And the last one, we don't need to look at either. So it's the first 4 will be useful for us. Now let's go to the example questions. It says solve for x. So I haven't put up the, the formula or the identity for this. So what we have is log 25 to the base 5 is equal to x. And there are 2 ways of doing this. The way done here is with a formula that you're going to need. So what you want to do here is get the antilog of both sides. So for me, that gets rid of the log to the base 5 from the left, and you're left then with just 25 on the left hand side. But when you get rid of it on the left, what it does is it brings the base up as a number and shifts the x up as a power. So I'll say that again. Get rid of the log to the base on the left, and what remains is just a 25. When you get rid of it, you're actually getting the antilog on both sides. And the effect that has is it shifts the base across to the other side as the number, and the number that was on the other side, which in this case is the x, shifts up as a power. So the next line that says 5x equal to 25, for me that's reversed. It should say 25 is equal to 5 to the power of x. What you can then do is write 25 as 5 squared, and if 5 to the x is equal to 5 to the 2, just compare the powers. X then equals 2. Okay, let's have a look at the next example. So get rid of the log on the left, and I should be left with x equals, and then the base becomes the number, so I get 4 to the power of 2, and the 2 was the number on the right hand side. So I would have x equals 4 to the power of 2. They've got it the other way around. And then 4 to the power of 2 is equal to 16. Will you guys do the next 6? You can pause the video. Here are the answers. And here is the next thing I'm going on to. So these are your homework. These will utilize everything we've done already, and I'd ask you to submit this on a Word document, take a photograph of it or whatever, and just give it to me on Edmodo. So I'd like to see this work done out.